You walk into a bank vault in 1973 Manhattan. Steel door weighs 4,000 pounds. Combination lock made by Mosler Safe Company, the same firm that built Fort Knox security. Tumbler pins inside precision machine to 1,000th of an inch. The bank manager tells you this vault has never been cracked. Not once in 42 years. You pull out what looks like a dull piece of metal. No teeth, no grooves. Just a flat magnetic block about the size of a pack of cigarettes. You place it against the lock. 30 seconds later, the door swings open. The manager's face goes white. You just beat a system that cost $500,000. The FBI called it the cleanest work they had ever seen. No explosives, no drilling, no damage at all. Just a small magnetic tool that turned every high-security vault in America into a suggestion. This script is researched and factual, using sources from the Federal Bureau of Investigation's declassified safe and vault entry investigation files from 1973 through 1978, and security analyses published in the Journal of Physical Security, Volume 6, Issue 3, 1974, which detailed magnetic manipulation vulnerabilities in Mosler, Diebold, and York safe systems used in over 80% of American financial institutions during that decade. These are not generic crime reports. These are the actual technical breakdowns written by the investigators who tried to figure out how someone bypassed systems that were supposed to be impossible to defeat. Now back to the information. Manager arrives at 7:45. Vault door is closed. Lock shows no signs of tampering. Combination dial sits exactly where it was left Friday evening. He spins the combination. Door opens. He walks inside. Shelf 3, position 12, empty. There should be $200,000 in bearer bonds sitting there, gone. Shelf 7, position 4. 3 safety deposit boxes forced open, contents missing. Total estimated loss that morning, $430,000. Unknown. No physical evidence of forced entry. Lock mechanism shows zero sign of manipulation. Lucy had worked safe jobs for 9 years. He had seen torch work, peel jobs, punch attacks. This was different. This was invisible. Amount, $270,000. Lock, pristine. No marks, no burns, no nothing. The bank's security consultant, a former Navy EOD tech named James Walsh, examines the lock for 6 hours. He brings in a jeweler's loop. He disassembles the entire dial assembly. He finds exactly nothing wrong. Walsh writes to the bank's board, "I cannot explain this entry. The lock functioned perfectly during my examination. There is no evidence any tool contacted the internal components." McGowan interviews 14 professional safecrackers in federal custody. None of them have heard of a method that leaves no trace. One guy, doing 15 years in Leavenworth for a bank job in Chicago, tells McGowan, "If somebody's opening Mosler vaults without leaving a mark, they're not using tools, they're using magic." We're talking about rare earth magnetic assemblies that did not even exist in commercial form until the late 1960s. The technology came out of military research, naval mines, missile guidance systems, submarine hull attachments. Neodymium iron boron magnets developed by General Motors research labs in 1966 produced magnetic fields 10 times stronger than traditional ferrite magnets. By 1970, small quantities were leaking into civilian markets. Most people did not know they existed. A few people knew exactly what they could do. A metal bar called a fence drops into the aligned notches. That action retracts the bolt. Door opens. The wheel pack sits behind a plate. The plate protects it from drilling or manipulation. Between the dial and the wheel pack, there's a drive cam. The drive cam connects to the wheels through pins. Turn the dial, drive cam rotates. Pins engage wheels. Simple mechanical system, extremely reliable, completely analog, no electronics to fail, no batteries to die, just steel and precision. Not enough to rust or degrade, but enough to respond to a sufficiently powerful magnetic field placed in the correct position. With the fence pulled out of position, it cannot drop into the wheel notches. With the fence unable to engage, the bolt retraction happens whether the wheels are aligned or not. Turn the dial, any combination, and the bolt slides back. Door opens. You have to know the internal architecture of this specific lock model. Mosler Safe Company manufactured 11 different vault lock variations between 1960 and 1975. Each variation had the fence positioned slightly differently. Diebold had 8 variations, York had 6. If you place the magnet 2 centimeters to the left of the correct position, nothing happens. 2 centimeters to the right, nothing happens. You have to hit the exact spot. Another dead end. Schematics were supposed to be restricted, but Mosler employed over 200 people in their Connecticut facility. Any machinist, any engineer, any quality control inspector could have walked out with drawings. In May 1972, 3 banks hit in 1 week. Philadelphia, same pattern. Vault entry with no visible damage. McGowan flies to Philadelphia. He meets with local FBI. They compare notes. Philadelphia banks used Diebold systems. Different manufacturer, same vulnerability. Whoever was doing this had cracked multiple lock types. Interesting to the meeting, one of the banks had just installed a new security camera system 2 weeks before the theft. The camera covered the vault door area. The tape from the weekend shows nothing unusual, but Chitwood noticed something odd. At 2:17 a.m. Sunday morning, there is a brief flicker in the image, less than a second. The kind of flicker you get from magnetic interference. Old video systems used magnetic tape. Strong magnetic fields could cause momentary distortion. Chitwood had seen it before when they tested metal detectors near the equipment. Manager says yes, required by fire code, keeps air circulating inside. McGowan looks at the tape again. Before the flicker, the grill shows a diagonal shadow across the left side. After the flicker, the shadow is gone. The door moved. Not much, maybe half an inch. The bolt retracted, releasing internal pressure, and the door shifted slightly on its hinges. McGowan subpoenas traffic camera footage from surrounding streets. Philadelphia had just installed automated traffic monitoring on major intersections. 38 cameras operating in the downtown area. McGowan's team pulls footage from the 3 nearest intersections. At 2:04 a.m., a white Ford Econoline van, no plates visible, drives east on Market Street. At 2:31 a.m., the same van, identified by a distinctive rust patch on the rear door, drives west on Market Street. 13 minutes inside. Enough time to enter the building, access the vault, load the contents, and exit. Detectives start calling it the Rust Bucket Crew. Not a clever name, but it sticks. McGowan gets authorization to contact safe manufacturers directly. He needs to know if anyone else has figured out the magnetic vulnerability. Mosler Safe Company sends a representative to meet with FBI in New York. The representative, a senior engineer named Harold Greenwald, listens to McGowan's theory about magnetic manipulation. Greenwald's face goes pale. He asks McGowan to repeat the theory. McGowan does. Greenwald says, "We identified that vulnerability in 1968. We issued a service bulletin to all clients recommending a retrofit shield installation. The shield costs $85 per lock. Approximately 12% of clients actually installed it." Greenwald explains that the bulletin was classified as an improvement recommendation, not a critical security flaw, because at the time, in 1968, rare earth magnets were not commercially available. The engineering team calculated that the magnetic field strength required to exploit the vulnerability exceeded anything a criminal could reasonably obtain. By 1972, the calculation was 4 years out of date. McGowan now has confirmation. The method is real. The vulnerability is real. But he still does not have a suspect. The Rust Bucket Crew operates across 5 cities. They hit banks on weekends when security is minimal. They never leave prints. They never leave tools behind. They never trigger alarms. The jobs are too clean, too professional, too consistent. This is not a bunch of amateurs who stumbled onto a magnetic trick. This is someone with deep knowledge, careful planning, and access to specialized equipment. These are the real investigative documents, not Hollywood versions. Now back to the information. But it is a radio frequency beacon, experimental technology, installed by a client who worked for Bell Labs. The beacon activates when moved. It transmits on a frequency monitored by a private security firm. At 3:22 a.m., the beacon starts transmitting. Security firm calls Newark PD. Police respond within 11 minutes. Too late to catch anyone, but fast enough to find something important. Tire tracks in the parking lot, fresh, from a vehicle with unusual treadwear. Forensics photographs the tracks. The pattern matches a Goodyear polyglass tire, common on vans and light trucks. But the wear pattern shows the vehicle is carrying significant weight on the rear axle, consistent with a cargo van loaded with equipment. White Ford Econoline van, rust patch on rear door, Goodyear polyglass tires with heavy rear wear. The officer runs the plate. Comes back registered to a shell company in Delaware. Officer calls it in. FBI gets notified. By the time agents arrive, the van is gone. The officer let it go after checking registration. Standard procedure. Nothing indicated the vehicle was connected to a federal investigation. The officer writes down the plate number, though. FBI traces the shell company. It leads to a P.O. box in Wilmington. The P.O. box rented by a man using the name James Morrison. James Morrison does not exist. Social security number traces back to a man who died in 1964. Male, 40s, wearing work clothes, drives a blue Chevrolet pickup. He collects mail from the box. Agents follow. He drives to a warehouse in industrial Wilmington. The warehouse is rented by another shell company. FBI runs background on the warehouse. It has been leased for 8 months. Lease paid in cash, 6 months up front. No business listed at the address. Utilities show minimal electrical usage. No water usage. The place is basically empty or used for storage. Spacing between the magnets, 43 millimeters. That spacing matches the internal dimension between the fence mechanism and the bolt housing on a Mosler Model 6 vault lock. Next to the device, technical drawings. Schematics for Mosler, D-bolt, and York vault systems. Handwritten notes in the margins showing measurements and magnetic field calculations. 4 magnetic devices total, each configured for different lock models. Approximately $12,000 in cash. Lock components, apparently used for practice and testing. A ledger book with dates and amounts. The dates match known bank thefts. The amounts match reported losses, but they are listed as percentages. Each entry shows around 60 to 70% of the actual stolen amount. Somebody was taking a cut. The blue pickup returns. Driver pulls into the warehouse lot. FBI agents move in. Driver sees them, throws the truck in reverse, tries to back out. Agents box him in, he stops, puts his hands up. They pull him out. Guy's name is Leonard Marks, 43 years old, resident of Cherry Hill, New Jersey, no criminal record, no prior arrests. McGowan interviews him. Marks refuses to talk initially. Then his lawyer advises cooperation in exchange for a reduced sentence. Marks starts talking. When he left Mosler in 1968, he took copies of the drawings with him. Not physical copies. He could not walk out with papers. He memorized them. Then he reconstructed them from memory over the next year. He realized that with a strong enough magnet placed in the right position, he could manipulate the fence mechanism on the locks he helped design. He spent months figuring out how to obtain neodymium magnets. They were not sold commercially. He contacted suppliers who worked with defense contractors. He claimed he needed them for experimental motors. He paid cash. By 1970, he had built his first device. He tested it on a Mosler lock he purchased from a surplus dealer. It worked. He refined the design. He built devices for other lock models. Then he needed funding and muscle. He could not do bank jobs alone. He contacted a guy he knew from his neighborhood, a small-time operator named Vincent Salerno. Salerno brought in 2 other guys. They formed a crew, 4 people total. Marks provided the device and the technical knowledge. Salerno handled logistics and entry. The other 2 guys were lookouts and drivers. Marks personally cleared $1.4 million. Defense argues that the banks were negligent for not installing the retrofit shields. Defense claimed the vulnerability was known and the banks chose not to fix it. Judge rules that criminal intent overrides negligence. Jury deliberates for 4 hours. Guilty on all counts. Salerno dies in prison in 1979 from a heart attack. The other 2 get paroled in the early 80s. Next to each name, a dollar amount ranging from $500 to $5,000. These were payoffs. Marks and his crew were not just bypassing locks. They were paying insiders for information, alarm schedules, security camera placements, weekend duty rosters. The magnetic device opened the vault, but inside, information made the job safe. 19 people were eventually charged with conspiracy and accepting bribes. 12 were convicted. 7 were acquitted due to insufficient evidence. The trials dragged on through 1975. The bank industry panicked. If insiders were compromised, if locks were vulnerable, if the whole system was broken, then what? Insurance companies started refusing to cover vault contents unless banks installed upgraded security. Mosler, Diebold, and York all issued mandatory retrofit bulletins. Every vault lock in service had to be retrofitted with magnetic shielding or replaced entirely. The retrofit program cost the banking industry an estimated $48 million between 1973 and 1976. And the external surface, the mu metal absorbed and redirected magnetic fields, preventing them from reaching the internal mechanism. Cost per lock, $120 installed. The shield did not make the lock stronger or the combination harder to crack. It just made the magnetic trick impossible. But the story did not end there. In 1989, a security researcher named Peter Field published a paper in the Journal of Physical Security. The paper described Marks' method in technical detail. Field argued that the case should be taught in security courses as an example of how technological advancement can outpace defensive measures. Field wrote, "The banks relied on locks designed in the 1950s. The locks were excellent for their time, but technology moved forward. Rare earth magnets became available. The locks did not adapt. The failure was not in the lock design. The failure was in assuming that a proven system would remain secure forever without updates. Every system has assumptions. Every assumption is a potential weakness. If the assumption is that certain tools or materials are not available to criminals, and then those tools become available, the system fails." Field's conclusion? Security is not a product, it is a process. It requires constant evaluation, constant updates, constant awareness of technological change. They remained in FBI evidence storage for decades. In 2003, the FBI donated them to the International Spy Museum in Washington, D.C. They are on display in the lockpicking and entry tools exhibit. A small placard explains what they are and what they did. Tourists walk by every day. Most people do not stop. It is just a small block of metal. It does not look impressive. It does not look dangerous. It looks ordinary. That ordinariness was the whole point. You could carry it in your pocket. You could walk past security. You could place it against a lock, wait 30 seconds, and open a door that cost $500,000 to secure. The device worked because nobody expected it. The banks built walls, they installed alarms, they hired guards. They did everything right, according to 1950s security standards. But Marks was operating in the 1970s. He had access to materials and knowledge that did not exist when those standards were written. The Marks case matters because it showed how invisible vulnerabilities can hide inside trusted systems. The banks thought their vaults were secure. The locks had never been defeated. The manufacturers had excellent reputations. Everything looked fine, until it was not. Randall wanted to test whether the method still worked on old locks. He contacted a bank that was decommissioning an old Mosler vault from 1967. The bank agreed to let him try. Randall placed his replica device against the lock. 32 seconds later, the bolt retracted. The lock had no magnetic shielding. It had been in service for 29 years and never upgraded. Randall wrote a report for the American Society of Industrial Security. The report was titled Legacy Vulnerabilities in Retired Security Systems. The bank destroyed the vault lock after the test. Private vaults in older buildings, anywhere that had not undergone the expensive retrofit program in the 70s. Randall's report prompted another round of security audits. Insurance companies required proof of magnetic shielding before issuing policies. The industry learned the lesson twice. The other crew members could not account for their portions. In total, FBI recovered about $900,000 in cash and assets. That left $3.8 million unaccounted for. McGowan believed Marks had hidden money somewhere, but he could not prove it. Marks denied it until his death in 2007. The box was in a small bank in Vineland, New Jersey. The bank had records going back to 1970. The box had been rented continuously under a false name. Inside the box, $340,000 in cash, wrapped in plastic, and a handwritten note. The note said, "For emergencies, LM." The sister turned the money over to federal authorities. It was eventually distributed to the banks that had been robbed, prorated by loss amount. The technical specifications of Mark's device were documented in FBI evidence logs with precision that borders on obsessive. Device 1, configured for Mosler Model 6 locks, measured 87 mm by 43 mm by 19 mm. Total weight, 212 grams. The aluminum housing was machined from aircraft-grade 7075 alloy. The two neodymium magnets were cylindrical, 12 mm in diameter, 8 mm thick. Magnetic field strength measured at contact surface, 11,800 Gauss. The spacing between magnets was not arbitrary. 43 mm placed each magnet precisely over the two anchor points of the fence mechanism in Mosler's design. One magnet pulled the fence pivot, the other pulled the fence tip. Both had to pull simultaneously to create the 2 mm displacement needed for bypass. He disassembled it completely, measured every component, documented every tolerance, then reassembled it and returned it to the dealer, claiming it did not fit his safe. The dealer gave him a refund. Marks used those measurements to build device 2. It took him 7 months of trial and error to get the magnet placement right. His workshop notes, seized by FBI, showed 143 failed configurations before he achieved successful bypass. He purchased a hydraulic press from a machine shop auction. He learned powder metallurgy from library books. It took him 11 attempts to produce a magnet with sufficient field strength and structural integrity. The first 10 attempts either crumbled during compression or failed to achieve adequate magnetization. The 11th attempt worked. He used that magnet for 2 years until it developed a crack. He made a replacement. Total cost to produce device 3, including failed attempts, $920. He was wrong. Electronic locks had shielding built in specifically to prevent electromagnetic interference. Device 4 failed every test. Marks kept it anyway, hoping to refine the technique. FBI seized it before he solved the problem. Suits filed by lock manufacturers against each other over patent disputes related to the retrofit shields. Mosler claimed their shield design was proprietary. Diebold claimed prior art. York licensed a shield design from a third party and got sued by both Mosler and Diebold. The litigation generated over 4,000 pages of court documents. Most of it settled out of court by 1978. Total settlements, approximately $19 million, split between multiple parties. Before the Marks case, 0 students identified magnetic manipulation as a threat. After the case became public, 92% of students identified it within the first hour of analysis. The professor who designed the case study, a guy named Roger Schell, wrote, "Knowledge of attacks transforms perception of security. Once you know a method exists, spotting it becomes obvious. The challenge is imagining attacks before they occur." Marks's magnetic device was not a brilliant innovation. It was simply the application of available technology to an old problem. The brilliance, if you can call it that, was recognizing that the old problem had not been updated to account for new technology. Underwriting requirements. All vaults had to undergo third-party security audits every 2 years. Audits had to include testing for magnetic vulnerabilities, thermal vulnerabilities, acoustic vulnerabilities, and radiographic vulnerabilities. The audit requirement added substantial cost. A comprehensive vault audit in 1975 cost between $3,000 and $8,000 depending on vault size and complexity. Small banks could not afford it. Many small banks simply stopped offering vault services. Safety deposit boxes disappeared from hundreds of rural banks between 1974 and 1977. Customers who had used those boxes for decades suddenly had to find alternatives. Explosive residue, drill bits. The Marks case showed that sophisticated attacks could leave 0 physical trace. Investigators needed new techniques. McGowan worked with FBI laboratory specialists to develop magnetic field detection protocols. If a lock had been subjected to a strong magnetic field, microscopic changes occurred in the metal structure. These changes could be detected using a technique called magnetic particle inspection. A ferromagnetic powder applied to the lock surface would cluster at points of residual magnetization. The technique was not perfect. It required the lock to be disassembled. It could produce false positives if the lock had been near strong magnetic fields for legitimate reasons, such as MRI machines or industrial equipment, but it was better than nothing. By 1976, FBI labs were using magnetic particle inspection on every suspected magnetic bypass case. They identified 7 additional cases that had been classified as unknown entry method and reclassified them as probable magnetic bypass. None of those cases were ever solved. The perpetrators were either different crews who independently discovered the method, or they were smart enough not to keep ledgers and devices in a warehouse. The recommendation was not legally binding, but most suppliers complied voluntarily. A black market emerged. By 1978, neodymium magnets were selling on the gray market for 3 to 5 times their legitimate cost. Demand came from various sources, some legitimate, some not. Researchers, hobbyists, engineers, and probably a few people who had the same idea Marx did but were 5 years too late. Lock technology accelerated in response to the Marx case. Electronic locks became standard faster than they otherwise would have. By 1980, over 60% of new vault installations used electronic or electromechanical locks instead of purely mechanical combinations. The electronic locks had their own vulnerabilities, but magnetic bypass was not one of them. Different attack surface, different defenses. The cycle continued. Attackers found new methods. Defenders responded. Technology moved forward. The journalist asked if he regretted it. Marx said, "I regret getting caught." The magazine's editor defended the decision in the next issue. We published this interview because security professionals need to understand the mindset of those who attack the systems we design. Marx provides insight into that mindset. The banks thought they were safe. The customers thought their money was protected. The insurance companies thought the risk was manageable. All of them were wrong. One machinist with magnets and blueprints proved it. That year, FBI digitized old case files to save storage space. The Marx case became electronic, PDFs and JPEGs instead of paper and photographs. The physical evidence remained in storage. The magnetic devices went to the museum. The vault locks were destroyed. The schematics were classified, not because they were secret, but because nobody wanted them freely available. Even 40 years later, some of those old lock models still existed in service. Small vaults, old buildings, forgotten places where the retrofit never happened. The auditors contacted each institution. 15 upgraded immediately. 2 argued the locks were grandfathered under old regulations. Federal regulators disagreed. The locks were upgraded by court order in 2013. The lock had been installed in 1961. 52 years. It had never been defeated, never been attacked, never been tested. Just sat there, vulnerable, protected only by the fact that nobody knew it existed and nobody tried. The credit union replaced it with a modern electronic lock as part of a general renovation. The old lock was thrown away. No museum wanted it. No collector wanted it. It went in the trash. A piece of history that could have been opened with a $100 magnet ended up in a landfill.